Welcome to This Explainer. Today, we're unpacking the absolute foundation of human discovery. We often think of science as this modern monolith of massive laboratories and insanely complex quantum equations. But the truth? Every single breakthrough in history is built on just two everyday cognitive superpowers that you and I use constantly.
So, here's a massive question for you. How do we actually know what we know about the universe? I mean, we weren't exactly there when the planets formed, right? And our eyes for sure can't see the individual strands of our own DNA. The simple answer is that scientists are basically historical detectives. They arrive at the scene of the universe, and they use incredibly specific tools to piece together the greatest mysteries of our existence.
Here is our roadmap for today. First, we'll master the tools of the trade with the twin pillars of science, followed by observation versus inference. Then, we'll tour history's greatest scientific minds by decoding the cosmos, unlocking the microscopic world, and finally, pioneering the modern age.
Section 1. The Twin Pillars of Science. Gathering clues and solving mysteries.
Okay, let's dive into this and establish our detective toolkit. The very first pillar is observation. Now, this isn't just casually looking around. It's the deliberate act of gathering objective information directly through your senses or by using precise measurement tools. The whole goal here is establishing pure, raw data. It's fantastic because it's not invasive. You can watch a phenomenon in its completely natural setting without altering its behavior at all, just gathering the factual clues exactly as they exist.
And that brings us to the second pillar, inference. If observation is finding the literal fingerprints at the crime scene, inference is figuring out who they actually belong to. It's the process of deriving a logical conclusion or making a prediction based on the evidence you just observed combined with your prior knowledge. Whether it's a human brain using logical reasoning or a massive machine learning model finding patterns to make predictions on unseen data, inference is how we actually solve the mystery.
Section 2. Observation versus inference. The rules of the game.
Now, what's really interesting about this is how different these two tools actually are when you put them head-to-head. When you look up and note that the sky is blue, well, that's a direct observation, a completely verifiable sensory fact. But when you deduce that the sky is blue because of a phenomenon called Rayleigh scattering, that is an inference. You can't literally see the light scattering. You deduce it through logical interpretation based on the data.
Naturally, neither tool is perfect. Observation is highly naturalistic and generally low cost, which is great, but it's totally vulnerable to reactivity. Where subjects act differently just because they know they're being watched. Inference, on the other hand, is amazing for speedy, scalable predictions, especially in modern tech. But making those massive inferences requires heavy computational resources, can raise some serious data privacy concerns, and crucially, it doesn't have perfect accuracy. Both require some deep critical thinking to avoid biases.
Section 3. Decoding the cosmos, from Earth to the stars.
So the crucial point is seeing how these historical pioneers layered these tools to completely reshape our reality. Galileo used pure visual observation to spot Jupiter's moons through a magnified lens. But observation has its limits. Sir Isaac Newton couldn't literally see gravity, so he used massive inferences to calculate the laws of motion and planetary mass. And, a fun fact, he did all this after narrowly dodging his mother's attempt to pull him out of school to become a farmer. That exact inferred framework then paved the way for Einstein to later infer that space and time are fundamentally intertwined.
Section 4. Unlocking the microscopic world, biology, chemistry, and the mind.
When we shift our focus inward, we see observation revealing these incredible hidden structures. You've got Robert Hooke looking at cork tissue to discover the cell, and Rosalind Franklin using X-ray diffraction to actually capture the physical forms of DNA. But inference is what turned those structures into cures that saved countless lives. Gertrude B. Elion inferred how to create non-toxic antiviral drugs for leukemia, and Louis Pasteur inferred the processes for vaccines. A pursuit he was so intensely dedicated to, he kept working on the rabies vaccine even after suffering a severe brain stroke.
You see, the overriding power of observation can completely rewrite what we think we know. Charles Darwin is a perfect example. He was raised in a Christian family in Great Britain and grew up firmly holding creationist beliefs. But his direct observations of nature were just so compelling that they essentially forced him to infer the landmark theory of evolution and natural selection. He realized that species that adapt to their environment survive while others perish. The physical, hard evidence completely overrode his prior assumptions. And this brilliantly illustrates how vital this overriding power of observation is.
For centuries, humanity just operated on this incredibly arrogant inference that only humans were intelligent enough to create tools. Jane Goodall shattered that completely. By engaging in deep naturalistic observation in 1960s Tanzania, she directly watched chimpanzees create tools and communicate, which fundamentally changed how we understand our own evolutionary relatives.
When these diverse thinkers combined observation and inference, they literally birthed entirely new industries. Marie Curie observed elemental properties to discover radioactivity, winning dual Nobel Prizes, and pioneered portable battlefield X-rays. Rachel Carson observed the brutal impacts of DDT, inferring environmental dangers that launched modern ecology. George Washington Carver looked at the humble peanut and inferred over 300 applications, like peanut plastics. Even the human mind wasn't off limits. Sigmund Freud used observational cues from his patients to infer the complex mechanics of the subconscious.
Section 5. Pioneering the Modern Age, the Technology Revolution.
Take a look around you right now. Chances are you're sitting in a lit room. Or maybe you're using Wi-Fi to hear this. Well, you are directly benefiting from the inferences of Nikola Tesla. While his rival Thomas Edison heavily pushed the direct current system, Tesla designed the alternating current, or AC electric system. His patents for the Tesla coil didn't just stop at electricity. They laid the very foundation for wireless transmission, remote controls, and radar technology. He observed the invisible forces of electromagnetism and inferred exactly how to harness them to power the entire globe.
Let's move to connect and see how this builds, tracking the compounding inferences of the computing leap. In the 1840s, Ada Lovelace observed a mechanical engine and inferred looping, the foundational logic of programming. A century later, Alan Turing built on that exact logic to decipher World War II codes and infer the famous Turing test for AI. 2 decades after that, Katherine Johnson used highly complex mathematical inferences to calculate the precise flight paths that safely put astronauts on the moon for Apollo 11. Observation provides the raw data, sure, but it is compounding inference that literally takes us to the stars.
Which brings us right back to you. The scientists we've discussed today weren't superhuman. They just mastered the art of gathering clues and solving mysteries. They looked closely at the world around them and dared to draw bold, logical conclusions from what they saw. So as you leave this explainer and go about your day, I want to leave you with this provocative thought. The universe is still full of mysteries waiting to be solved, from the macro to the micro. What will you observe and infer in your own life today?